Hello guys, in today's class we'll be doing combined footing design. We are going to be using Staad.Pro Advanced Foundation. So quickly do that. The first thing we do is to rerun the analysis. Yeah. Then we click on this foundation design here. We have foundation design standalone, which has its own icon on my desktop, but we can as well click here and it takes us to foundation design. So instead of going to the standalone, just click here. So you look at your left hand side under this excluded from design, we select our load combination. So you just select all the combination from SLS to Ultimate. I will include it here. Then I'll click on Start Foundation Advanced. It's as simple as that. To take us to Start Foundation is loading. Let's wait for it while it comes up. Okay, the foundation design is up now. So I would like to combine this support number 5 and support number 11. I want to design this as combined footing. Yes, or I can pick any one that is close as well and design as combined footing. Okay, so let me design 5 and 11. 5 and 11. So the first thing we do is we come to job setup, click on create a new job. Yes. If you are using a small screen laptop, you need to drag this thing out so that you can see clearly what you are setting up. Then from here you type the name of the job. You can type duplex combined footing. From here I'll select the type of foundation. You have pile cap, mat, combined, so I'll put it there. Then you select the code, Euro code. I will use Euro code here. Yeah, that's Euro code 2. SI unit, I'll use standard international. Then assign to selected support. So I'll need to select the support, the two supports I want to combine. So I'll select this. Hold it down the control key, click on the 2. That's that. Okay, then I can as well list support here 5 and 11. 5. Okay, so I'll continue. Point at this place, all the load combinations, selected load cases, I'll include all. Click on this, include all. Click on create job. So it says job duplex combined footing has been successfully created. Click OK. And under this one, click on selected node. They are still selected. So As the it has linked the two. So I'll close. So this is the job we created. Click on this, then you start our settings. The first one is concrete and reinforcement. So unit weight of concrete 25, the reinforced concrete, yes. Minimum bar spacing, okay. For here I can put 100 for minimum bar spacing, no, 150. 150 will be fine. Minimum bar spacing, maximum bar spacing, let me use 200 here. Strength of concrete is okay. Yield strength of steel, well, yes. Minimum bar size, footing bottom. Maximum bar size, footing bottom. Okay. Minimum bar size, okay. Maximum 12 and 16 is okay. 12 and 16 is alright. The minimum pedestal bar spacing, maximum pedestal bar spacing. Okay, let's leave it like that. You can set as this one set as default, yes. That means next time you open foundation design, you will see all these ones you have set here like this. Nothing will change. Then if you want to, you can modify. Okay, I'll close. Then click on soil, cover and soil. Pedestal clear cover, use 50. Footing clear cover, okay, still 50 is okay. Unit weight of soil, can use 18. Base value of soil bearing capacity. So from your geotechnical report, you should be able to get the bearing capacity. So it depends on the nature of the soil in the area where you want to site your project. You we have bearing capacity ranging from 1 to 300 depending on how strong the soil is. So in this case, I'll be using 200, a good soil bearing capacity. Then the factor of safety of 3. Footing embedment depth, I can use 1. Type of depth, fixed bottom. Surcharge pressure, I can just put a surcharge pressure of 1. Depth of water table, this one is also from your technical report. They will give you the level of water table at rainy season, when rain is falling. What's the water table, such that you use this to know if your building or structure is going to suffer uplift when the water table is high. So that's the essence of this. So if you say the water table gets to the top or the surface of the foundation, so the software will be able to check the effect, the uplift, the extent of uplift. When the water table is high, is it going to uproot your structure? It's going to affect the stability. So that's the essence of this water table. So we can just leave it at 0.8 mm, 0.8 meters. Yeah, this one is okay. You can click on yes to make it our default. I'll say okay. That's for soil. Then go to footing geometry. The fixed left overhang. Yes, okay. Minimum left overhang. So minimum left. Let me just put 0.5. So you can use minimum of 0.5. Then um, 0.5. Minimum width 0.5. So minimum thickness, I will use minimum thickness of 200 mm. The maximum length, the length of this, okay, let me use the maximum length of 2000 mm. Maximum width, okay, 1500. Okay. Maximum thickness Okay, I can accommodate 300. Length increment increase by 100. Each time if the length is not sufficient, your software automatically increase it by 100 and check again. Thickness increment is okay. Then click yes. That's good. Sliding and overturning. Coefficient of friction 0.4 is okay. Factor of safety against sliding 1.5 is correct. This one is according to Eurocode. That's that. We have national annex, okay. British national annex is good. Then we need to go and put pedestal for our footing. We need to put pedestal. So we go back to this place, foundation plan, pedestal and anchor bolt. We locate support 5 and 11. Support number 5 and 11. So support number 5, consider pedestal yes. I'll put yes. Yeah. So you look at it. Okay, this is 9 and 11, sorry. It's 9 and 11, not 5 and 11. 9, I will say yes. Yeah, see there already. Then 11, scroll down. 11, I'll see yes again. So now pedestal height at 11 can make it 1 meter. Pedestal width and length 0.225 by 0.225. So let me copy this. Copy, Ctrl C and paste it on. That's good. Say okay, close it. You see my combined foot already have pedestal shooting up. Yeah. So I'll come down here and click on design. Okay, sorry. I will batch my loads. That's the last thing. Come to load. I need to batch this load. I need to tell this software which one is my serviceability limit state and which one is my ultimate, because the software is going to use the serviceability limit state to size the foundation, to size the footing, while using to size the footing and use the ultimate to do the reinforcement design, to design for strength. Yes, so what I'll do is I'll select all the SLS, geotechnical and the rest of them, equilibrium for overturning and show that this one. Yeah, it has selected all the serviceability limit state. Yeah, including geotechnical equilibrium, and this one is going to be used for my checks. This serviceability limit state is going to be used, and geotechnical is also going to be used for the sizing. Equilibrium is going to be used for uplift and overturning. So now for all those checks, that's serviceability limit state. Then we have strength combination, which is ultimate. So here I'll select service to tell the software that okay, these ones I have highlighted now are the service under service limit state. Now click on batch. That's right. Then I'll select the ultimate limit state and click select ultimate, highlight ultimate here and click batch. That's good. So the software is going to use serviceability limit state for our sizing, then use the ultimate for the strength design. So we now come down here and click design. See yes. Do you want to analyze and design? Yes. You can save as. In this way you have to know the folder you are saving it to, create a folder, save it with a name, so that next time if you want to continue from there, you just go down and click it. Then this one is just to save to the foundation design software. You save into the software. The software has a file that it saves everything to. If you click just save, automatically the software can save it where it has been saving other work. Yeah, so I'll just click save, and we wait for the analysis um, to run and the design to run as well, so we can see the output result. So if you are still enjoying my classes and you are yet to subscribe, I'll urge you and beg you to just click the subscription button, subscribe, click the like button, give me a positive comment, share my video with your colleagues in the office, your classmates. As you do that, I appreciate. Thank you very much. Okay, the result is out, analysis is done, design is done. So this is combined foundation design. Euro code, this is the Euro code result summary. This is showing the summary table. Left overhang 1 meter, right overhang 1 meter, overall length is 2.9 meters. The thickness of pad is 0.2, that's 200. This is just the summary of the result. And main steel top reinforcement is 12 mm at 200 mm center to center. Main steel bottom reinforcement 16 mm at 200 mm center to center. Secondary steel top reinforcement at distribution is 12 mm at 200 mm center to center. The same thing for the bottom steel. And double footing normally we have top and bottom reinforcement because of sagging and hugging moment, which is obtainable in combined footings. That's why you see top and bottom reinforcement. But for isolated footings, it's usually only bottom reinforcement because there is no hugging moment involved. Yeah, so combined footings is a sketch of what we did. You can see 0.2 the thickness from here to that ground level and the rest of them. The pedestal height is 1 meter as we put there in our input data. Is the sketch of the foundation of the combined footing. The software has done a great job. You can see the pedestal information, good pedestal, yes, pedestal shape rectangular, which is as well square. Pedestal height 1 meter, this is 225, 0.225, eccentricity 0. So all this, the result is smooth, very okay. Cover and soil properties. You have pedestal cover 50, unit weight of soil, base bearing capacity 200 as we used. Yes, bearing capacity. So soil surcharge, depth of above foundation, depth of soil above foundation, concrete and rebar properties. These are our inputs. Yes, yeah. Applied load service stress, applied loads. The report is a comprehensive one. Let us go straight to bearing pressure check. You can see the pressure at top left corner. This is 58. Maximum pressure at top right corner 122. Maximum pressure at bottom right corner is this one. Um, Pressure at bottom left corner is this. Gross bearing capacity is what we use to design. So all these things are less than this, so the bearing capacity is okay. See, there is no uplift and no pressure adjustment is necessary. Otherwise, to account for uplift, areas of negative pressure will be set to 0 and the pressure will be redistributed to to the remaining corners. So it displays the same thing, all of them are less than 200. It's okay. Stability check for stability against overturning moment printed against load axis. Yeah, that's the report. See, factor of safety, required factor of safety is that. You see resisting moment let's consider this particular one. The resisting moment for this load case then is this. Resisting moment is this. Yeah. Putting thickness calculated based on the ultimate load case. Okay. So everything is alright. See because of the nature of the foundation is double footing, you see sagging moment and you see hugging moment. That's why we have top and bottom reinforcement. Yeah, this is shear diagram. So that's for the report. If you click on geometry, you see the shows the foundation we are designing, the geometry detailing. There are a few detailed drawings here, but you can ignore this and make your own drawing. LCDC drawings are better. Yeah, this is general arrangement drawing, shows the footing itself, the pad and the pedestal positions. The calculation sheet is this one, the graph, there's moment and the shear force. Okay, if you can as well print the click print calculation sheet, you print the calculation sheet, save it as PDF and PDF format, and that's all for the foundation design. So we'll end here. You can save it or you print to go send to printer, or you you select PDF direct and print to PDF, convert to PDF, and that will be your report. So under here we also have the summary. Summary is also here, as you can see. So the software is a good one. When the printed work is this, so you can open it as a PDF file. This is the design report, very comprehensive. So we end here. Next time we're going to pick up another project, but before then I will do math foundation, show you how to design a math foundation, and yeah, it's going to be very um impactful. So stay tuned, subscribe to my channel, and keep expecting, keep your expectation high, because I'm going to be meeting up to your expectation. I'm going to be feeding you with a lot of information based on as regards to civil design, structural designs with Staad.Pro software for now and AutoCAD. As time goes on, we progress with other software. Yeah, yeah. Okay, we see you next time. Thank you.